Now we move on to the next topic is process capability. Process capability is indicated in the form of CP. First, we're going to know about the process capability definitions. What is process capability? It is a measured or inherent variations of the product turned by the process. What is process? The unique combination of machine or tool or method or materials or people engaged to produce the product manufacturing. And the capability is nothing but based on the tested performance to achieve the measurable results. So the combination of process and process capability is indicated by the plus 3 sigma to minus 3 sigma. So totally it is indicated as 6 sigma, where sigma shows the standard deviation of the process under the state of the statistical control. There are the values indicated in various notations such as CP indicates the process capability index, CPK is the minimum process capability index, where PP is the process performance index, where PPK is a minimum process performance index. Process capability is a tool that helps to determine the ability of the process to meet their specification limit, the required specification limit. Once we have the process in control, then we can answer whether the process is capable of meeting the required specification or not. When company can use this tool because of the setting of the new process or setting of the new specifications, or to identify the reasons why the product from the particular process do not meet the specification. So on that type of characteristics, we can go for the process capability. And the process capability is also defined as the spread of the output of the process around its center values. We have already discussed the in the chart, normal chart, there will be three lines. One is the center line, one is upper limit, another one is lower limit. So the peaks are varying between the center line to upper or center line to lower values. So the process said to be highly capable when all outputs from the process is lie closer to the center line. When the process said to be statistically controlled, then all the output process will be lies between the minus 3 sigma to plus 3 sigma, in the interval of minus 3 to plus 3. Whereas the process capability formula is always calculated as sigma, where sigma indicated as R. The process capability is also known as the capability of the process to produce the expected capability of the product. When the upper limit and lower values is indicated in the form of UCL or LCL. UCL is nothing but upper control limit. LCL indicates lower control limit. Where the control quality, the customer quality is the confirmation to the customer specification within the tolerance band. So whenever we'll get to meet the customer's requirement, we have to get the feedback from the customers. Then the feedbacks, based on the feedback, the requirement of the customers will be satisfied. So this will be indicated in USL or LSL. USL is nothing but upper specification limit. LSL is indicated as lower specification limit. And this process capability is always in the lines between the measurable estimate to level to the process output within the specification limit. So it's comparison between the output process to the process specifications. Whenever we're going to improve the process capability, then we have to go for the steps such as statistical process control tool to monitor the process whether it is reaching the capability or the desired level. When it is not reaching the desired level, then we go for the action to be taken for the rectifying the problems. Or when it is not meeting, then investigate the concern and help to improve the improvement of the product. There are the various applications or the advantages of the process capability which is used for the product process design or process scale up or qualification stage or the commercial manufacturing stage. The relationship between the process variation and specification width, where there are three graphs are represented for the relationship of the variability, where the first graph indicates the process variation specification limit given in the interval of minus 50, the minus 15.8 to 16.2. So the specification limit or the meets the specification width, which means the lower the values between the 13.4, where the second graph indicates, B graph indicates the process variations outside the specification limit, where the peaks are given as a branded or lengthy values are shown here, which means beyond the 16 point limit, and the left hand side also beyond the 15.7 values. Whereas the graph C indicates the process variability within this specification limit, where the peak values are starting from the region of 15.9 to reaching the 16.1, where based on this graphical term the CP values are derived as CP is equal to 1, CP is less than equal to 1, or CP is greater than equal to 1. Where CP is equal to 1 is the process variability just meets the specification, where CP is less than equal to 1, it's not capable of producing the specification limit, whereas CP is greater than equal to 1, then the process exceeds the minimum specification limit. Then the assessing the process capability will use the formula is CP is equal to upper specification limit minus lower specification limit divided by 6 sigma. So this graph is indicated for all the four graphs represents the green and light green, yellow and red colors. All it meets the specification when the only one graphs is coming to beyond the lower and upper specification limit. So that is the not meeting the specification requirement, where this graph is totally out of the center line. So we this type of graph we can go for the CPK is upper specification limit minus mean values divided by 3 sigma, where our mean specification limit minus lower specification limit divided by 3 sigma. This is the formula which is used for finding the non-centered process, where the CP index is also called as process capability index. This capability index is used for finding the particular production process. When goes to the evaluating the process ability to meet the two sides of the specification limit, we go for the formula is CP is equal to upper specification limit minus lower specification limit divided by 6 sigma. Where CP is equal to 1, then the process will be the position to generate the output, and that will lie within the specification limit. Whereas CP is greater than 1, then not is capable of meeting the required specification, where less than equal to 1, then potentially incapable of meeting the specification limit. And the values are when it is reaching the capability process capability limit, then the values is less than the 1.33 values, where the larger capability index is better the quality, then limitation of the capability index is does not meet the requirements. And CPK index, this CPK index will measure the process of performance, and this will help for summarizing the process ability to meet two sides of the specification limit, where CPK is equal to x minus LSL, where x is nothing but center line divided by 3 sigma, or USL minus x divided by 3 sigma. This is the formula for CPK. Where CPK is equal to 1, the process is said to be a marginally capable. Where CPK is less than 1, then process is said to be a incapable. So greater than 1, then process is said to be a capable one. So the CPK values is always around or equal to 1, then it reaches the values of 1.33. where the prerequisite for the CP and CPK to be effective, which means the comparison between the CP and CPK values. If the process is not stable, then you go for calculating the CP values and CPK becomes meaningless. Whereas the process has to be statistically under control, then there is no assignable variations in the CPK. The output have to be normally distributed and the same has to be represented by the populations. So this is also the comparison between the CPK is equal to CP is equal to CPK when the process is centered, where CPK will be always less than or equal to CP. Then CPK is greater than 1, then it implies the process conforms the specifications. So CPK less than 1, the process does not meet the specifications. CPK is negative, then it implies the values outside the specification limit. So this is the diagram shows where CP values and CPK values are low. When the first red line in the red round indicates that CP values is low, CPK values also low. Where the second graph, CP values high when CPK values also high. So which means the shooter are showing the good eye and reaches the center values. So all the points are meeting the center values. Whereas the third curve, it is not meeting the required stage, where CP is high, CPK is low. This is the graphical representation of the data collected from the control chart and indicates the plotted the graph and indicates the values of higher and lower limit. So the all the values are within the limit, then it